Now that we know what a function is, we want to be able to evaluate a function. But not only do we want to be able to evaluate any function, we want to be able to evaluate any function in function notation, which means instead of writing y equals, we're going to write f of x equals, or g of x equals, or h of x equals, or really any letter. But those letters, that f of x, that g of x, that h of x, is just going to represent y. So when I look at this first example here, I want to know which table corresponds with the function f of x equals 3 times x minus 4. Well, again, this is just that function notation that I just mentioned. This means the same thing as y equals 3 times x minus 4. But because sometimes we deal with more than one function, we need to be able to describe functions in ways other than just saying over and over again, y equals, y equals, y equals. So we're going to, again, start using this function notation. So in order to match up a table and a function, all I'm going to do is ask myself, if I plugged these x values in to my given function, would I get these y values back? Well, plugging -2 into my function, I'm going to go ahead, and the way it's written is f of -2 equals 3 times -2 minus 4. Remember, I only distribute if I can't do what's in the parentheses, and I can do -2 minus 4. It gives me -6. So I will have 3 times -6 is -18. So notice that this did not work. So I'm not going to choose that table. Looking at the next table, again, I'm going to start by plugging in -2. So I already know from what I saw here that f of -2 should be -18. Well, that worked. So far so good, but I have to check my other values as well. So when I plug -1 in, I have f of -1 should be 3 times -1 minus 4. I don't have to distribute, so I get 3 times -5, order of operations, which is -15. Well, notice that that's not -15, so my second table doesn't work either. Well, process of elimination tells me it probably should be my third table. And notice that, and I plugged -2 and I got -18. -1 gave me -15. Just for some practice, I am going to go ahead and plug 0 in. So f of 0 equals 3 times 0 minus 4, which is 3 times minus 4, which is -12. So every x value did give me the y value that I wanted in this table. So that is going to be my choice. In example 2, instead of giving a table, I'm given some different functions, f of x, g of x, and h of x, and I'm asked to find some different values. So I'm going to go ahead and do that. So the first value I'm asked to find is f of 6. Well, what does this mean? This means go to the f function, so I'm going to ignore these two, go to the f function, and plug 6 in for my x's. This 6 is representing what my input or my independent variable should be. So I'm going to go ahead and do that, and I get 2 times 6 minus 3 is 12 minus 3, which is 9. So once I plug that 6 in, it is just order of operations. Letter B, g of 3, tells me to go to my function g. All right, I'm there. And now I'm going to plug 3 in for all of my variables. So I'm going to go ahead and say that g of 3 is equal to -2 times 3 squared minus 4. Order of operations, I get -2 times minus 4, which gives me -18 minus 4. Signs are the same, so I add, and I get -22 as my final answer. On the last one here for letter C, I'm trying to find I'm trying to evaluate h of -2. Well, that tells me to go to my h function and plug in a -2 for all of my variables. So in this case, I have 2 x's that -2 has to go in for. So I'm going to have 3 times -2 squared minus 4 times -2. Order of operations, I start with my exponent. Oops, and I wrote an equal sign again. I don't know why I keep doing that. Now I can multiply. I have 2 places to multiply. Well, that gives me 12 minus a minus becomes plus, so 12 plus 8 is 20. Looking at my final example, if I'm asked what point does g of 5 equal 9 represent? Well, notice up here in these examples I just did, didn't the f of 6, didn't the 6, wasn't that my input or my x value? And then after evaluating, didn't that give me my, essentially my f of x value, which as I mentioned before was the same thing as y? So didn't that give me my y value? So it's going to work the same way. I'm plugging in an x value of 5 and getting back an output or a y value of 9. So I'm going to go ahead and say this represents the point 5, 9. Looking at example 4, it's the same way. What point does f of negative 3 equals 2 represent? Well, I'm inputting negative 3 and I'm getting back this output value of 2. So I'm going to go ahead and say that that represents the point negative 3 as my input or my x, 2 as my y. So even though this is a new concept, it really is just looking at and evaluating functions like we've done before. We just need to make sure that we get used to this new notation of f of x, g of x, h of x, and so on and so on. Bring these notes with you to class to use them as an aid as you work through your practice, and we can talk about any questions you have then.